A very, very, very good morning to you all and welcome. My name's Michael.
And I'm Mickey.
And welcome to The Silly Scientist. Now, science is all around us. Science is in this room here. Science is in our homes. Just about everywhere you go and everything you see has some sort of science involved in it. So science isn't just something we do in a little room called a laboratory. Science is all around us all the time. One of the things, really important thing that we need in science is we need water. We need water for life. We need water for growth. And as you'll see, we need water for lots of our experiments. So we'd like to start off with a song this morning. And what we'd like you guys to do is when you hear the word water, I want you to go like this. I want you to go have a really big slurp. So I'll just get my guitar, Mickey. So
No worries.
when you hear the word water, you know what to do. Here we go. Let's have a practice. Ready? And water. Ooh la la. I tell you what, they're pretty loud, aren't they, Mickey? Let's try that again. Ready? And water. Oh, they're going to be fantastic. Here we go, guys. You ready? Well, I went into the fridge and got myself some water. Ooh la la. I filled my mouth up to the brim. It was rolling down my chin, but I still wanted more till it dribbled on the floor. Well, I went into the fridge and got myself some water. Ooh la la, with ice. Oh, I tell you what, Mickey, they were fantastic, weren't they?
Were.
You know, Mickey, I'm not sure, but I was having a listen, and
Yeah.
I actually think. I think the girls are louder than the boys. And I've got an idea.
Yeah.
Let's try the girls first and then the boys.
Cool.
So, hands up the girls.
Hey, you're not a girl, Michael.
Oh, hang on a minute. I'm not a girl, am I? Here we go.
Come
Just
on,
the girls.
girls.
You ready? Well, I went into the fridge and got myself some water. Oh, you go, girls. You go, girls. I filled my mouth up to the brim. It was drooling down my chin, but I still wanted more till it dribbled on the floor. Well, I went into the fridge and got myself some water. Go, girls, with ice. Oh, they were fantastic,
sure
weren't they,
were.
Mickey? Well done. And hands up the boys. Hands down. Now, boys, the way of making this a little bit louder is first of all, put our tongues out a little bit like this, and then we go round and round like this. Oh, no, don't lick your eyebrows. Here we go. You ready, boys? Just the boys. Just the boys. Well, I went into the fridge and got myself some water. Oh, you go, boys. You go, boys. I filled my mouth up to the brim. It was dribbling down my chin, but I still wanted more till it dribbled on the floor. Well, I went into the fridge and got myself some water. Go, boys, with ice. Oh, they were fantastic, weren't they, Mickey?
They sure were.
You know, having a listen to it that time,
Yeah.
Mickey, I think it was a draw. I think the girls and the boys were exactly the same.
I agree. Well done, guys.
So, Mickey, girls have had a shot. They were brilliant. Worked as a team. Teamwork works well. Well done, girls.
Yep.
Boys have had a shot. They were brilliant too. Worked together as a group. We've had a shot.
Yep.
Girls have had a shot.
Yep.
Boys have had a shot.
Yep.
It's always important that everybody gets to have a shot. That's everyone, isn't it? Have we missed anybody out?
I reckon. What about the parents?
Oh, what about the parents?
Yeah.
Yeah, and we all know what lovely big voices they've got, don't we, boys and girls? Yeah,
Sure
we do.
do.
Here we go.
Come
Let's
on,
try just the parents. Well, I went into the fridge and got myself some water. Oh, you go, parents. You go, parents. I filled my mouth up to the brim. It was dribbling down my chin, but I still wanted more till it dribbled on the floor. Well, I went into the fridge and got myself some water. Keep going, parents. Keep going, parents. Keep going, parents. Girls and boys, all the parents' heads have gone purple. With eyes. Oh, give yourselves a very big round of applause. Fantastic. Well done, guys.
Great job.
And that now brings us to our first experiment. And we're going to talk a little bit about some chemical science to start off with, and we've got some wonderful things here. Now, in my home, I have got a very, very wonderful, highly intelligent pet elephant. And my elephant, his name is Walter. And Walter's a lovely elephant. I really love him. But the only problem is, Walter, he loves to wake me up really, really, really early in the morning. Now, don't get me wrong. I love waking up early in the morning. The only problem is Walter, he comes in and I'm sound asleep and he says, Michael, you awake? Hello, wakey, wakey. And I love being woken up early in the morning, but the only problem is Walter has got really, really, really bad peanut breath. So every morning we have to make Walter some elephant toothpaste. So we're going to start off here. As I say, we're going to have a chemical reaction here. So first of all, we've got our observation flask here, and we've also got some water. So we're going to put a little bit of water into our cup there. So pour some in there. Now to that, we're going to add some yeast. Now yeast has got carbon dioxide, which is a gas, but it's got lots of oxygen in it. So Mickey's going to put some yeast in there. So we put a few teaspoons of that in there. Sometimes you see in a loaf of bread, you see all the bubbles in the bread. That's actually the yeast rising. That's the carbon dioxide rising because it's quite a light gas. So we put that there. Now also, we've got our observation flask. Now into that, we're going to put some hydrogen peroxide. So we're going to pour a little bit like that. Now, hydrogen peroxide, sometimes people use it for dyeing their hair. It's really good as a hair dye. Or sometimes, if you cut yourself, really good. It kills germs really well. And the other thing it does is ripens fruit really well. So you can ripen up fruit because it's got lots and lots of oxygen in it. So we put that one in there, lots of oxygen in there. Now, to that, we're also going to add a little bit of dishwashing liquid. So we're going to pop some dishwashing liquid in there, like so. You can see that one going in. We'll give it a little bit of a stir up like that. So we've got our... Now, we're looking for a chemical reaction. We're looking to make some of Walter's elephant toothpaste. We're also going to add to that a little bit of food colouring. So we're going to pop some food colouring in like so. There we go. No reaction yet. So we've got that one there. So we're going to give it a little bit of a mix around like so. So we've got all of our ingredients. Now, we've got our yeast here. Now, this acts as a catalyst, so it speeds something up or changes a reaction. So let's see what happens. We're going to put some of our yeast in with our hydrogen peroxide, and let's see if we can see what happens. And we'll pop it in like so, and whoa! And we have elephant toothpaste. So there you see, guys, that's a chemical reaction, and we get heat as well. You can see some of the heat coming off of that as well. Now, what you've got there, whoo, that's fantastic, isn't it, Mickey? So what you've got there, you've got lots of oxygen in the hydrogen peroxide and lots of oxygen in the yeast. And when you mix the two together, they make even more oxygen. But the really, really important ingredient here is the Morning Fresh, is the dishwashing liquid. That looks like elephant toothpaste.
It sure
and
does.
it is. But
Yeah.
what that is millions and millions and millions of tiny little bubbles. And all of the oxygen has got caught into those tiny little bubbles and come straight up the middle. Oh, what a fantastic experiment. And you guys can do that really, really easily.
Yes.
Now, I'm not sure how you're going to get rid of that.
I'm not sure either. I'm working on that one.
Now, sometimes, I don't know if you guys have heard of the phrase an optical illusion. So optical meaning our eyes, and illusion is a kind of a trick. So what it is our eyes are tricking our brain, an optical illusion. I'll give you an example. So if I take these two banana shapes, and I show you these two banana shapes, and I'll put them exactly the same at the bottom. And if you have a look up at the top there, you can see this one here looks a bit longer and a bit higher. Now, if I swap them around, watch what happens. I'll put this one in front now. Okay, swap that around. Now, this one looks a bit higher and a bit longer. If I put them both together like that, I get a really big smile. They are exactly the same size. So your eyes are looking around here. This is an arc, and this is an arc. And your eyes are looking around that arc and that arc at the same time. And they send a message to your brain saying, because that arc is bigger than that one, then the whole thing must be bigger. But it's not. It's an optical illusion. You get 2 bananas in a banana bowl, and exactly the same size, and put one banana behind the other, and then ask somebody, say, hey, which one's bigger? They'll always say that that one there is the bigger one. An optical illusion. Now, I've got another one here, Mickey.
Yes.
And I'll just grab this one down
I'll help you
here.
with this one, Michael.
What's that? Yep.
I'll help you with this one.
Excellent. Okay. Now, if you can just come out. Now, I want Mickey and you guys, I'm going to show you a completely empty box, okay? Now, I want you to get your fingers and point them towards the box, and I want you to say after me, abracadabra!
Abracadabra!
Hocus pocus!
Hocus pocus!
Put some ribbon
Put some ribbon
in the box.
in the box.
So we're going to close the box, completely empty box, close the box. I'm going to turn around, and I'm going to open the box up.
Wow!
La la!
Oh, how'd you do
You can
that?
take that, Mickey, and pull that one out.
Look at that.
Excellent. Keep it going.
Ooh,
Don't stop.
awesome.
Keep it going.
That's amazing, Michael.
Excellent. Another optical illusion. So your eyes are tricking your brain. I've got another one. Stay there, Mickey.
right,
I've
no
got one more
worries.
there for you. And this one here. So everybody, fingers towards the book again, and fingers towards the book, Mickey. And I want you to say after me, abracadabra!
Abracadabra!
Hocus pocus!
Hocus pocus!
Make the page
Make the page
completely blank.
completely blank.
Here we go. Let's have a look. Whoa, completely blank
Oh,
page.
you just brought a blank book today, Michael.
Oh, I've got the wrong book, have I?
Did you bring the wrong book?
No, I've got the right book, Mickey. Here, I'll just sprinkle a little bit of magic dust on there.
All right. Okay,
Yeah.
let's hope this works.
I want you guys, again, fingers towards the book. Say after me, abracadabra!
Abracadabra!
Hocus pocus!
Hocus pocus!
Put some
Lines?
put some lines on the page.
On the page.
Now, I want you to think of your favourite thing to do. Absolute favourite thing to do. It might be riding a skateboard. Might be riding a scooter. It might be playing netball. Might be social distancing. Who knows? Think of your favourite thing to do, and think of, as we said, the black outline, and abracadabra, hocus pocus, put some lines on the page. Let's have a look. Whoa!
Wow.
I tell you what.
That's pretty good.
It's not
Did I
bad,
do
is it?
that?
You certainly did.
Better work out how I did
Here we
it.
go. Look at that. All of our favourite things to do.
That's pretty cool.
And one more. Everybody, fingers towards the book. Abracadabra!
Abracadabra!
Hocus pocus!
Hocus pocus!
Put some colour
Put some colour
on the page.
on the page.
Now think of your favourite colour. Put it in your mind. And on the count of 3, I'm going to get you to go whoosh and send me your favourite colour. Ready? 1, 2, 3, whoosh. Okay, pressure's on now. Drum roll, everybody. Brrrr. Abracadabra, hocus pocus, put some colour on the page.
Oh, wow. And my favourite colour is
Whoa.
there. Purple.
I tell you what, that's pretty
Yeah.
clever, guys. Well done.
Fantastic.
Must have been that magic powder that did the
Must
trick.
have been.
Fantastic. Look at that. So
That is
they're
really
all
good.
optical illusions. They're our eyes sending a message to our brain, tricking our brain, and we think we're seeing something that we're not actually seeing. Now, we've got another experiment here, and what we'd like to do is, first of all, we've got our nice big jar there. Now we're going to put a little bit of vegetable oil into our jar. So if we just pour a little bit of vegetable oil, okay, there we go. So pour that one in there, about halfway if you can, Mickey. Excellent. Now, we're going to pour some water in a minute, but you know what? A lot of what we find out in science is by accident. So we'll be doing something, we'll be trying to make something, and we find out something else by accident. Play-Doh. Everybody's played with Play-Doh. You guys have all played with Play-Doh. It was made by accident. It was actually made, a man made some Play-Doh up, and what he used it for, he didn't even call it anything, he just called it stuff. And you got this stuff, And when you had an open fire in your lounge, the soot from the fire used to go on the walls. And he made this stuff, and you rub it on the walls. And he used to rub it all around on the walls to get all of the black soot off of the walls in his lounge room. Now, his wife was a kindergarten teacher, and she came in one day and she saw him doing this, rubbing this stuff on the wall. She said, "What are you doing there?" He said, "Well, I've got this new stuff, and it gets all of the soot off of the walls." And she said, "You know what? Can I take some of that?" So she took it, she put some food colouring with it, and she took it to her kindy the next day, and the kids went berserk. They played with it, they made shapes with it, they threw it at each other. They even ate it. Oh, yeah. But it was made by mistake, and she made millions and millions and millions of tiny little tubs of Play-Doh, all by mistake. Now, we want to say hi to Jason, Emma, Kathy, Tribe
guys.
FM, and another Kathy, and Sue and Roxanne, Sean and Trent. Hi, guys. Thanks for joining in with us. Great to see you.
Hi.
Now, we're going to put some water in here. Just before we do, I want you guys to think what's going to happen. So what do you think's going to happen when we put the water in there? So let's pour the water in there, Mickey. See what happens. Okay, water's going in. Right. Now, we're using warm water there, so you can see a little bit of steam. So pour it, yep, pretty much to the top. Excellent. Okay, so you can see there's lots and lots of bubbles, but you can see the water's gone down to the bottom and the oil has gone up the top. Now, a lot of people, they look at that and they go, the oil is much lighter than the water. It's not lighter. We don't use the word lighter. We use a word called density. So the oil is less dense than the water. It's not lighter, it's less dense. Now, to that, we're going to add a little bit of red food colouring. So pour that in. So pour a bit of, that's great. Yep, a bit of that in there.
Yep.
Okay, and we mix that up. So you can see a bit more, if we can, Mickey, just a bit more.
Sure.
That's it. So you can see there's lots of bubbles in the middle, but you can also see the
It'll go down there.
yeah. You can see a little bit. I don't know if you can see that there,
Oh,
but
that bubble.
all of it's nearly about to pop. Whoa. Okay, now to that.
Maybe.
Whoa, there we go. There we go. So the food colouring's broken there. Now to that, we're going to add some Alka-Seltzer. Now, Alka-Seltzer has got carbon dioxide in it, and the carbon dioxide is quite light. So we'll pop that in there, Mickey. Yep. So now the carbon dioxide starts to release out of the tablet and starts pushing through the water, through the oil. The oil and the water don't mix, okay, because density. And there's another thing going on here too. Water has got like a positive charge to it. So water's got like a battery in it, like a torch battery. And any liquids with a positive charge, they all want to hang around together. And oil has got no charge in it at all. So like when you turn a torch battery on and nothing happens. So oil's got no charge in it, and the water has got lots of charge in it. So it's a bit like the crows and the power. Of course, the crows are on top. Yeah, absolutely.
What about a little bit of green?
So we put a bit of green in there. Okay, so you can see that it's stopped now because all of the carbon dioxide has come out of the tablets. So we'll pop another tablet in. So we've got red and green. And away it goes. Whoa.
Oh, look at that. At least it's not messy.
There we go. Look at that. And all that will keep going and going and going until all of the carbon dioxide comes out of those tablets. And you see that's pretty much just about ready to stop there now. So it's all come out and that's ready to stop there. Excellent. That's a great one. Now, there's another experiment here. I'll just grab those off you. Thank you, Vicky. This is awesome to do. And this is all about a movement of air. And it's just what we call air pressure. I mean, it's a big word. We go, oh, air pressure, what's that? All that air pressure really is when air is moving around. So what we do is we take a balloon and we put a 5-cent piece in the balloon like so, put that in there like that, and we blow the balloon up. la la. We take that one and we tie it off like so. Now, okay, so we've got our balloon. If you're going to do this experiment, very important, you put the 5-cent piece. You might be able to hear that rattling around. Now, air pressure. All air pressure is when air is moving. Okay, so a good example of air pressure is Mickey's got a hairdryer here. So when there's nothing going, there's no air pressure. She turns it on, air pressure. Turns it off again, no air pressure. Now, I'm going to pop this on top of there like so. Okay, now, so there's no air pressure at all here. So we're going to turn on some air pressure and let's see what happens. Whoa! Okay, so we've got the air flowing really, really, really fast on the sides. Now, to that, we've got a ping pong ball, and we're going to try and put one of those in here like so. So we pop a ping pong ball in, and whoa!
Hey.
There we go. And we'll try another ping pong ball. Let's see how we go. Whoa! Whoa. Now, so, yep, there we go. So you can't see it, but on the sides, the air is going really, 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 really fast. Really fast, just like if you're driving down a freeway and the cars on the outside are going really, really quickly and the cars on the inside are going really, really slow. So that outside's going really, really fast. Inside is going really, really slow. It's what we call air pressure. And lots of our weather systems are made with air pressure. Now, watch what happens when we turn it off. Okay, no air pressure. Oops. Everything falls apart. We'll grab it there. Oh, you got it there, Mickey.
Yeah.
There we go. So we'll just bring that, turn that one back on again. And let's have a look. Whoa. And there we go. And one in there like so. And another one in there like so. And we'd like saying, hi, Tyson. How are you? Kylie, Austin, Sienna, Maddie, Lynn. Hi,
wow.
Everybody. How are you? Welcome to the Silly Scientist.
Hi.
So, air pressure. Now, watch what happens when we turn it all off.
Do you want to catch it,
I'll
Michael?
try and catch the balloon, Mickey.
On the three. One, two, three. I didn't tell you I can't count.
That's right. Thanks for that. Thanks for that, Mickey.
That's okay.
Now, so that's a little bit of air pressure, and you can see, well, you can't see air. You can see trees waving at you. You can see lots of paper sometimes in a whirly, but you can't actually see air moving at all. You can see what it does, as I say, but you can't see it actually moving. If you could see air, I'll show you what it looks like. So I've got this one here. So if you could see air moving, we've got that one there. So if you could see it, we'll get our thing going. Now let's have a look. Okay, so we've got our air going, and let's see. Whoa! So this is what air looks like if you could see it moving. Woohoo! Oh yeah! Whoop! That one just slowed down a little bit.
Oh.
Now I'll get going. Up.
The wind died down, did it?
There we go.
Toilet paper.
Ah, fantastic.
Hard to come by.
Yep, excellent. So if you could see the air, that's what it would look like. Excellent. I'll just grab these bits and pieces there. Lots of fun, that. Fantastic. Now, this experiment here, you probably, if you're going to try it, might be best to try it outside because, it can be a little bit messy. Don't do it in your bedroom, please, okay? Do it outside. So first of all, what we do is we get ourselves a bottle of Pepsi Max. The no sugar works the best, okay? So we take that one and we take our lid off like so, okay? Now, to that, we've just got a little tube, okay, just a clear tube, and what we've done is we've just put in the bottom, we've just put a little clip. So it's just a paper clip. So we've just pushed the paper clip through, and that helps to stop the Mentos going through. So if you just pop the Mentos down there, Mickey, and we'll grab that one. So So I want to just get that nice and thin. Okay, so we just load up the Mentos like so. That one will go there, that's it. So you just load them up on top of each other like so. Put them in there. And again, this is what we call a chemical reaction, okay? And scientists aren't really 100% sure why this does what it does, but it's to do with the surface area of the Mentos. There's a large surface area. So we put all that in there like so, and then we take that one, okay, and you've got to be kind of quick with this one. So
Very quick.
so we're just going to push that down into there like so, okay. Now, you take that one like so,
back.
and we're going to pull the pin out and run. Here we go. 1, 2, 3, go. Whoa! There we go. Now, as I say, try not to do that when in your bedroom, okay? Very, very important.
It's very, yes.
And that's a chemical reaction. Great activity to do and lots of fun. Yeah, we'll get rid of that one there.
Oh,
you're going to, yep.
I'm not sure what we'll do with that one. Just at this point in time, we'll turn this one on.
Now, so if we can have the lights just dimmed very, very slightly. Now, this here, it's called a lightning ball. And obviously, we've got here, this is a sphere shape. Okay, so a ball shape is what we call a sphere. Okay, that's it. Fantastic. That looks looking great. Now, inside of this ball is a gas that we call neon. Now, neon is a very, very unstable gas. And when you mix neon with electricity, it actually lights it up. So we've got a little thing in the middle there. It's just a very strange name. It's called an anode, but all it means is just that electricity comes out of it. So the electricity's coming out of that ball, and obviously the glass is stopping it, so it goes to the edge. Electricity always wants to try and find its way to the earth very, very quickly. You watch what happens. When I put my finger on the ball, watch what happens. There you go. Okay, so you can see it's chasing my finger around. And what's happening is the electricity is trying to get to the earth as quickly as it can. And I'm what's called a conductor. So electricity will go through me. So you guys have got to be really careful with electricity. You don't touch electricity. But this ball's okay because it's got the glass. But when I touch it, you see it tries to go through me and down to the ground. If I can take a pencil. So this is a non-conductor. This is not a conductor. So if we put that against the ball, you can see nothing happens. Okay? So that's why, if you're having a look at a power cord, that's why it's got plastic around it, because the plastic is a non-conductor and stops you getting electrocuted. So, yep, Mickey, you can put your fingers on there.
Look at that. That's pretty cool, isn't it?
Yeah.
Could watch this for hours.
And we could, so pen back on there. And it's great, you could just put your fingers on it.
Yeah.
So this is called a lightning ball. You see lots of times if you're driving along at night, you might see a Pepsi or a Coca-Cola sign, or all of those signs, they're called neon signs. And the reason they're called a neon sign is because they're full of this neon gas. Okay? And so we can go round and round like that.
Yep.
Awesome little experiment and great fun.
Mm.
Fantastic. Thanks, Mickey.
Okay.
Now, have we got our bag there? We'll show got that one there. Excellent.
We want to make some more mess, do we?
Now, let me stress, this one here is not an optical illusion, okay? So what we do is, first of all, if you could just come round, Mickey,
Yes.
we're going to fill this up, put a little bit of water in there, so keep it going, don't stop. Excellent. So we've got our bag. That's probably enough, or a little bit more, just a tiny bit. Yep.
Might as well get rid of it all.
Yep. So we've got our water there. Now, to that, we're going to add just a little bit of food colouring. Excellent. Thanks, Mickey. So now what I'm going to do now is I'm going to seal this bag up at the top. Okay, so I've got that one there. I'm going to seal it up like so. Okay. Now, as I said, this is only water and food colouring, okay? So there's no special solution to turn it into jelly. It looks a little bit like jelly, but it's not, okay? So now...
I'll hold the bag and you can do the...
Right, well, you want it now. I want you to just... now you're going to push it through. Now, should we hold it there, or do you want me to hold it up here?
I reckon hold it up above your head.
Above your head? Now, you're going to push that through, Mickey.
All right.
Okay, so we're going to count to 3, and Mickey's going to push it through. Ready? And 1, 2, 3.
Are you scared? You should be.
I'm scared.
All right. Come back here.
I want my mummy.
Oh, she won't help you.
Here we go. Ready? We're going to count to 3. She's going to push it straight through. And 1, 2, 3. Push, 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 and let it go. Whoa.
Wow, look at that.
Okay. Now you look at that, you say, oh, wow, how on earth did that happen? Well, as I said before, we find out a lot of things by mistake. And one of these things here, we normally use a pencil to write with. But today, we're using it as a plug. So we're pushing it straight through, and it's acting as a plug. So it's just stopping the water from coming out. Finding lots of things by mistake. You all know a microwave oven. Everyone's had a microwave oven, had a pasty or something out of a microwave oven, made by mistake. A microwave oven was first made, it was a microwave radar gun. And somebody made it to detect speeding. 59, 64, 103. But what they did is when they were checking the people speeding, they had a chocolate bar in their top pocket. And they noticed that when they were checking the speeding, the chocolate bar in their pocket started to melt. And they thought, why is that melting? And then they worked out that the heat from the microwave gun was melting the chocolate. So he took it, put it into a little box, and made a microwave oven. So the microwave oven made completely by mistake. Kellogg's cornflakes, same thing. Mr. Kellogg, his name was, John Kellogg, he left something on the stove. And he came back, went, oh, that's right, I forgot something on the stove. Came back and found this crisp little thing on the stove. And he thought, he tried it. He said, ooh la la, that's nice. And he ate it and he loved it. And that was 100 years ago, and they're still making Kellogg's cornflakes now. Now, ready for the next one, Mickey?
Yep.
Okay, we're going to count to 3. Mickey's going to push it right through. Ready? And 1, 2, 3. And push, 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 push. Let it go. Excellent. There we go. Now, there's something else happening here too. So the pencil is acting as a plug. So that's the first thing. But also, when we seal the bag at the top here, no air can get into the bag and no air can get out. And when you've got a situation where no air can get in and no air can get out, we call that a
vacuum.
That's right, a vacuum. So the vacuum also stops the water from leaking out of the pencils.
Let's show them.
Just to show that there's no tricks or anything like that. Okay, so if you just hold on to that one, Mickey, pull them out.
Oh.
Whoa, whoops.
That's all right.
That's getting there, yep.
We'll just add to it.
There we go.
Oh, look at that.
Excellent, fantastic.
So all
Great
of that,
experiment,
yep.
very, very easy to do and lots of fun.
Yes. We'll just
Now, I've got another thing here I'd like to show you. It's an instrument. And this one here, you probably might know what this one is. If you're not sure of it, this is a didgeridoo. Now, the didgeridoo, this is the only instrument in the world that's made using what we call biological science. So biological science is just things that are living. So we're part of biological science, Mickey and I, but the roof, say, isn't, because the roof's made of tin. So anything that's living is part of biological science. And what we do is we take a branch off of a tree, we put that right on top of a termite's nest. Now, termites are tiny little, we call them ants. They're not really ants, they're little insects. But what they love is they love wood. And they eat their way all the way through the middle of the didgeridoo. It takes about a month to get a didge that big. And then what we do is we take that, we pack it in clay, pack that all in clay, and we put that into the fire. And what that does, first of all, the clay stops the didgeridoo from burning, but also it takes all the moisture out of the wood. And you listen, the didge becomes really, really hard. And then the traditional Aboriginal people would decorate the didgeridoo depending on which part of Australia they came from. Because the didge was only played in the top end of Australia. So from Darwin, around about across to Broome, and around about across to Townsville. So that was the top end. That was the only place it was played. It wasn't played down here in South Australia or New South Wales, just only in the top end. Now you can, as a science experiment, you can take a glad wrap roll. But please make sure you use the end of the glad wrap roll, okay? So you don't want to come into the kitchen and come in and go, la 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 la. Ooh, glad wrap. Wee, wee, wee. And then mum or dad or whoever's looking after you, they'll come into the kitchen and they'll come in and they'll go, la 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 la, might make a cup of tea. La 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 la. Ah. Ah. Ah! Who did this? That was me. I'm making a didgeridoo. Would you like to join me? Wee! Wee! So be very careful that you use the end of the glad wrap roll. Now, we'll try and start our didgeridoo, shall we, Mickey?
Yep.
So, first of all, I might give it a zip start, okay? Here we go. So we're going to try and zip start the didgeridoo. Here we go.
Oh. I reckon you need a little bit more choke there, Michael.
Right, a little bit more choke. Here we go.
Yep.
Let's try a little bit more choke.
And some petrol.
A little bit more petrol. Okay, here we go.
Here we go.
Here we go. We'll
start.
count to 3 and see if we can get it happening. Ready? And 1, 2, 3.
Oh, well done, Michael.
Oh, thank you very much.
Yeah.
Now, when I'm playing the didge, I'm actually breathing. I'm breathing out through my mouth, so I make this sort of sound. So it goes like this. And this is what you hear on the didge. And at the same time, I breathe in through my nose. So I'm breathing out through my mouth and in through my nose at the same time. And
that's called circular breathing.
Circular
Very
breathing.
hard
Now,
to do, actually.
Actually, Mickey, if we just show everyone, so we've got a microphone. So if you just put that next to my nose, just go very slowly.
Okay.
Slowly. Stop. Help me. Mickey's trying to put a microphone up my nose.
Oh, it's big enough.
Oh, thanks a lot. I want my mummy. Okay, so if you listen very carefully, you'll be able to hear I'm breathing out through my mouth and in through my nose at the same time. Here we go. Can you hear the breathing in and out? Now, I can make different animal sounds on the didgeridoo. Mickey, can you think of some animal sounds that we might be able to make?
My favourite is the kookaburra.
Kookaburra.
Yep.
Okay, let's try the kookaburra.
Okay.
So we'll see if we can do the kookaburra. Here we go. Kookaburra. What else have we got?
Elephant.
Oh, elephant. Okay, that's a tricky one. So here's an elephant. Elephant. Have you got any others there, Mickey?
Giraffe.
Giraffe.
A giraffe.
Right, okay, here's a giraffe.
Do you know what a giraffe sounds like?
I know what a giraffe sounds like. Here's a giraffe, okay? It goes like this. Okay, what's next?
That's because a giraffe is the only animal in the world that doesn't have a voice box.
No voice box?
I just wanted to trick you.
Okay.
What about
else we
a
got?
lion?
A lion.
Yeah.
Okay, let's try a lion.
And I reckon maybe we should finish it off with a whale.
A whale?
Yeah.
Okay, here's the last one. So here's a whale. Let's see what a whale sounds like.
Well done, Michael.
Thank you very much. So that's the only instrument in the world that's made using biological science. So made using living things. I think that's we've pretty much come to the end of our show today, Mickey. So it's a bit of a sad time, but
it is. But
if you guys are in your lounge or wherever you are, I want you to look at somebody in the lounge, look at them, and on the count of 3, I want you to say, "You are the best." Ready? 1, 2, 3, go!
You are the best.
Oh, fantastic. And we'd like to say hi to Ali and Lisa and Julie. We hope you guys have had a fantastic day with the Silly Scientists today. And take care, everybody, and we'll see you again some other time. See ya.
See ya.
Bye-bye.
Bye.